Hello, everybody. This is Mr. Cousage. We are up to Chapter 2-5, Rational Functions. Don't forget to write the date here. Rational functions look like this. They can be longer, but they have a fraction bar, like that. Okay? Rational, ratio, fraction. All similar. So do you remember when we talked about parent graphs and the graph of 1 over x looks like this? And this is a quick sketch, but basically the graph comes in this way, and it never reaches the y-axis. And then same thing this way, it goes like that and goes like that, but never reaches, gets closer and closer, but never reaches the x-axis. So I hope you remember that. An asymptote, okay? An asymptote is a line that the graph approaches but never reaches. So you can have an asymptote anywhere. There's two types. There's vertical and horizontal, right? So if you look, there's a line right here that the graph from both sides approaches but never reaches. So we say this line right here is an asymptote. It means that the graph approaches it but never reaches it. Okay? It happens to be going up and down, so it's a vertical asymptote. You could have a horizontal asymptote going across. So notice this graph is approaching the asymptote but never reaches it. It's approaching that line that we call the asymptote. Now, where is the vertical asymptote? Well, the vertical asymptote here is at x equals -2. So we say, for this graph, the vertical asymptote is -2. The horizontal asymptote here, going across, is at at y equals 3. The horizontal asymptote is at y equals 3. Okay? Kind of have an idea of an asymptote is a line that the graph approaches but does not reach. Okay, here's the rule for the day. It looks like messy, but stick with it and it does become simpler. So suppose you had some polynomial, short or long, over some other polynomial, short or long. Okay? So we can split it up into like this, where the first term has a power, and same thing on the bottom, a coefficient, a power, a coefficient, and a power. Right? Well, just by looking at how it starts, never mind what the rest, just by looking at how it starts, we can determine the asymptotes. First, let's look at the vertical asymptote. Vertical asymptote, we'll call VA from now on. That's when the bottom, this function or this polynomial, when that is equal to 0. Whatever x makes that 0, the whole bottom 0, that is your vertical asymptote. We'll see an example, right? So we say the vertical asymptote is at that x, whatever x makes the bottom 0. Right? When the bottom, the bx, the bottom, is 0. How about the horizontal asymptote? Well, in this case, there's 3 possibilities. And you check the powers, right? The highest power up here, the highest power down here. 2 numbers. Well, if you're... Hold on. I always do this, huh? The horizontal asymptote has 3 possibilities. And we look at the powers. These first 2 powers here. Okay, if your top power is smaller than your bottom, like say this was 2 and this was 3, right? That's what I'm saying here. If your top power is smaller than your bottom power, then your horizontal asymptote is simply at y equals 0. Okay? The axes, right? The x-axis going across like this, y equals 0. What if these two, this is not smaller than this, but they're equal? Well, if they're equal, then you kind of cancel them, and whatever you left over with these numbers here, that is your asymptote. Suppose you had 2x to the fifth, 3x to the fifth. Well, the x to the fifth will cancel. You ignore them, and you're just left with 2 over 3. That's your answer, 2 over 3. Okay? What if the other way around? What if the top power is bigger than the bottom power? Well, then you're done. There is no asymptote. There is no horizontal asymptote if that's the case. Okay? So let's look at an example. Here is my example. Right? A rational function. So, let's find the asymptotes. First, let's find the x, right, that makes this bottom 0. So we're looking for the vertical asymptote. And to find the vertical asymptote, look at the notes, we need to figure out what makes this bottom, what makes this denominator 0. Well, we can do this in our head, right? You can go to the side and say, oh, when is x plus 3 equal to 0, minus 3 minus 3? Oh, x equals negative 3, that's when it's 0. But you can see that if x is negative 3, this will be 0. Done. I found the vertical asymptote. It's at x equals negative 3. Excuse me. It's at x equals negative 3. And I even drew it for you, right? The asymptote would be there. Did you see how I figured out the vertical asymptote? Now, the horizontal asymptote. We gotta look at the powers, right? Now, if I was to rewrite this, what do I have in terms of powers of x? Here I have x to the power of 0, right? No x. Here I have x to the 1, right? So as you can see, the top power is smaller than the bottom. So what did we say when that happens? When the top is smaller than the bottom, then your horizontal asymptote is simply y equals 0, which is right there. That's y equals 0. Okay? So we found the vertical asymptote and the horizontal asymptote. Well, can we graph it to see what it looks like? Well, I know that it's going to be approaching this line here and never reaching it, right? Because I just found out that's negative 3. And it's going to be approaching y equals 0, right? That's y equals 0 here, right? So what does it look like? Gee, I don't know. Is it like that? That would work. Like that? That would work. Like that? Like that? Well, we don't know exactly where the graph is. Well, why don't we plug in some points? If x is 0, then 0 plus 3 is 3, 6 over 3 is 2. So when x is 0, oh, so we're here, in this section here. Well, how far do I go? Well, we have no choice. You have to stop here. You have to approach here, and you have to approach here. So I'm pretty much done, right? So your graph has to do this, right? That was the whole point of finding the asymptotes, right? I know that I can't go past this line, and I know I can't go past this line. This is an intercept, huh? This is the y-intercept, and that helped me graph it, which is what I want to talk about next, the intercepts. We already talked about intercepts, so I'm not going to take too much time talking about the intercepts. But really quickly, let's talk about the intercepts. How do you find the intercepts? Do you remember this? Well, if you want the y-intercept, well, let x equals 0, and you can solve for y and find the y-intercept. If you want the x-intercept, well, let y equal 0, and you can find the x-intercept. Okay? Here's another example. For this example, find vertical asymptote, horizontal asymptote. Which one do I have first? Y-intercept or x-intercept? Y-intercept. Wow. All four of them. All four things. Well, let's get going. The vertical asymptote is when the bottom becomes 0. Oh, this is similar to the other one, huh? So the bottom is 0 when x is negative 3. Done. Right? Vertical asymptote is at x equals 3. So that line, x equals 3, 3 minus 3 makes 0. X equals 3, that is your vertical asymptote. What about the horizontal asymptote? That's when we check the powers of x. Right? Oh, look at that. The powers are equal. What do we do when the powers are equal? Look at your notes. When the powers are equal, the x's cancel, and we take the numbers in the front here, which happen to be 1, 1, 1 over 1, which is 1. I put some notes here. So the powers are equal, so you get 1 over 1, which is 1. So my horizontal asymptote is y equals 1. Done with the horizontal asymptote. Now, how do we find the x-intercept? Well, you let y equal 0. If you let y equals 0, remember fx is the same as y, right? Put a 0 here. If you let y equals 0, then the only time it can be 0 is if x plus 4 is 0. You can't have x minus 3 0, right? You can't have the bottom. So the only time this is equal to 0 is when x plus 4 equals 0, and we're talking about x being negative 4. All right? If you want, you can cross multiply, right? This is equal to 0. This is equal to 0. You can look at it like an equation, right? Multiply both sides by x minus 3. Shall we do that really quick? You can look at it like an equation. 0 equals x plus 4 over x minus 3, right? So if I put a 1 here, I cross multiply 0 times this thing, 0 times x minus 3, 1 times x plus 4. So this goes away. 0 times anything is 0. 1 times x is x. 1 times 4 is 4. Minus 4 minus 4. And there you go. X is equal to negative. Wow, that's a lot of work just for a little. You could just see that, right? You could just see that this fraction equals to 0 when you get a 0 on top, right? So it has to be negative 4. I found my x-intercept. The x-intercept is at x equals negative 4. What is the y-intercept? Well, that's when we let x equals 0, right? 0, 0. Those were x's before. So what do we get? 4 over negative 3, which is negative 4, 3, right? I'm done. That's the y-intercept, negative 4 over 3. Now I have enough information to get a good graph going. Okay, let me just show you the whole graph, and you can copy it. Okay, pause, copy it. Okay, now that you copied it, is it correct? Sure it is. Look, first of all, we know we're going to put dotted lines for our asymptote. So the vertical asymptote is at x equals 3. There it is. There's the vertical asymptote. I'm not supposed to go past that line. I get close to it, but not go past it. The horizontal asymptote is at 1. There it is. Y equals 1, right there. Okay? My intercepts are, right, the x-axis, the y-axis, where do I cross them? X equals negative 4. I cross the x-axis at x equals negative 4, right there. So my graph has to go through there. And y equals 4/3, which is 1 1/3 negative, 1, 2, 1 1/3 about there. So those are my, so I have to go through here, right? And the other one has to be up here. So this is a rough sketch of the graph, right? I didn't make a mistake and put it up here. If I put it up here, that means my y-intercept would be somewhere here. But because the intercepts were down here, I know that this part has to go here, and the matching part has to go up there. Okay? All right. I know it's a lot. Okay, so do I have any more? No, let me leave you with a problem just like this. Okay? So you're going to find all four parts. All four parts. The function is going to be different, but you're going to find all four parts. Here is the try problem that I'm leaving you with. I'll even give you a hint. Okay, so now you're supposed to know what these words mean. Find the asymptotes and intercepts, and then you'll have enough information to get a rough sketch of the graph. Okay, here it is. Okay, here is your function. So when is the bottom 0? I'm giving you a hint. It's very hard to tell, but if you factor it, you can tell when the bottom will be 0, when the denominator will be 0. And I'll give you a hint. There's 2 of them. What? 2 vertical asymptotes? Yes, that could happen. So just follow the rules, do the best you can, and we'll finish this in class. Okay, bye-bye for now.